I'm going to make a short video here just to talk about DeMovire's theorem, how you use complex numbers in multiplication, division, and then taking them to powers. And we're going to do one other thing, and just in case you didn't get that from the printed notes, this is a super easy concept. It shows up in your review guide, and I just wanted to kind of make sure that there's no confusion when you multiply two complex numbers like you see here. So I've got z1, which is 2 times the cosine of 130 plus I sine of 130. We have z2, which is 3 times the cosine of 50 plus I sine of 50. So we have two complex numbers in polar form, and we want to be able to multiply them together. It's super easy to do. I'm going to write out the formula for it, and then I'm going to actually do the math with the two numbers here. So when you do that, you take R1 times R2. So the two radii, you're going to multiply them together. So it would be this one case, it would be 2 times 3. And then you're going to take cosine of theta 1 plus theta 2 plus I times the sine of theta 1 plus theta 2. Right? So this is my generic formula. If I apply this to the two problems above, what happens is we're going to have 2 times 3 would be 6. That's going to be cosine of 130 plus 50. It's going to be 180 plus I sine of 180. And that's it, right? And of course, we can write that in shorthand, 6 CIS 180 if it's a free response type of question. Sometimes you'll see that in multiple choice questions even. But this, as well as this, is essentially the correct answer. I don't really prefer either form. I usually write it shorthand just because it's easier. When we divide, okay, we're going to do the same kind of thing, and you're going to notice a lot of similarities here. It's going to have R1 divided by R2, and then you're going to have the cosine of theta 1 minus theta 2. That's going to be plus I sine of theta 1 minus theta 2. Exactly what we probably could have guessed. You're going to divide the R values, and then you're going to subtract the angle measures. If we take that apart, we're going to simply say it's going to be 2 divided by 3. I don't really have the option of changing the order. So it's the first one divided by the second one, because that's what it says. It's z1 divided by z2. And it's going to be cosine of, now this also has to be in the same order. We're going to do 130 minus 50. If I subtracted it backwards, if it had said theta z2 on top instead of z1, like what you see right here, I would subtract them backwards, and I would have a negative angle, and I would probably leave the result as just a negative result. But in this case, it's going to be 130 minus 50. That's going to give us 80 here, plus I sine of 80. And of course, the shorthand version of that is 2/3 CIS of 80. Just in case you're curious, CIS, and that's where we get that. It's just a shorthand way of writing the answers. Either of those two methods are totally fine. The last part is when we take it to a power. So we're going to take one of those two vectors, or not vectors, but one of those 2 points. We're going to take z2. We're going to say 3 cosine of 50 plus I sine of 50. And what I really wanted to do was I wanted to take these things to a power. In this case, we're going to take it to the 4th power. Generically speaking, the formula would be this. It's R. We're going to call that to the nth power. So if it was like z2 to the n power, we're going to let the n represent the power. There's going to be times the cosine of n times theta plus I sine of n times theta as well. And that's the whole formula. So let's apply that to this question. So we're going to take 3 to the 4th power times cosine of 4 times 50 plus I sine of 4 times 50 as well. So we're going to have 81 cosine of 200 plus I sine of 200. And that's it. That's what. And of course, if you wanted to write it shorthand, you'd write it as 81 CIS 200. Either way, both are correct. And so this is essentially a way for you to use polar form of a complex number to multiply them together, to divide them, or to take them to a power. Pause the video, go back and rewatch that section if that was confusing. Make sure that you know the formulas that we really focused on. There's 1, there's 2, and there are the 3 different formulas that we're working with. I would make sure to get used to that, make sure you can do that without any problems. I want to talk about one other thing, and that's about how to determine whether a vector is parallel, orthogonal, or neither one. Now, be careful. This is really perpendicular is another way of saying orthogonal. I want to give you 2 methods. We did go over this at one point, but I would just want to kind of hit this in one short video so that some of you may not have caught it. You may have missed this part of it in one of the videos. But when I have 2 vectors, let's just suppose that we have vectors 1, 2, and we have the vector, let's say 2, 4. So there's 2 ways I can judge if something is going to be parallel. The quick and easy way is if I can see one vector and I can say, look, if you multiply that first vector by 2 times 1 and 2 times 2 to give me this, and I get exactly the second vector, that's a guaranteed parallel idea, right? So multiples, right? If I multiply this vector by a factor of 2, I get the exact same vector here. That's an easy way for me to do it. Now, sometimes it's not so obvious. You've got fractions or you've got some kind of unusual values to work with. Here's the easy way. We want to talk about the slope of the vector, right? Slope is y divided by x. So what we're going to do is we're going to do that for both vectors, right? So v1 would be equal, we'll call this v1. This is going to be v2. Vector 1 would be 2 divided by 1, right? Which is just 2. Vector 2 would be 4 over 2. That would also reduce to 2. If these 2 values are the same, we have parallel vectors, right? If they're not, it's not parallel. That way, it doesn't matter if I have fractions, if I have any kind of weird situations happening, I can always do that, and I can determine if they are parallel or not. The secondary test, in fact, I usually try it in this order first, and then I would try this one second. And if neither one of those, then I know it would be neither, right? So there's no test for neither, it just fails both first 2 tests. If we had a vector where we would say this is 6, let's say 10, and then we had the next vector to be, let's say, let's make it -5 here and 3. And I want to know, is this vector orthogonal? Is it perpendicular to each other? Are they? If I were to find the angle between them, I would get 90 degrees. The dot product is how we do that. So v1 here, v2 here. We're going to say the x products multiply together, or the x values multiply together, and it's not a vector, so it's just a number. So this is going to be v1 dot v2. So we would say 6 times -5 plus 10 times 3. This gives us -30 plus 30, which is 0. So yes, this would be orthogonal. If your dot product is 0, you have orthogonal vectors. Now, if for some reason, now there's no real particular order to this. You can do perpendicular first, you can do parallel first. But if one of them fails, you have to do the other. If they both fail, then it is neither. All right, so both fail, you end up here. Okay, and that's it. Do the dot products, check the slopes if you have to. Normally speaking, those are pretty simple, pretty straightforward to do. Hope you don't have any questions, but if you do, you can either re-watch the video or you can email me and I'll be happy to get back with you. Have a great day.